Hello, and welcome to TI Precision Labs. In this video, we are going to discuss the HDMI DDC bus. HDMI is a popular video interface that can carry both video and digital audio from a video source to a sync device such as a TV or monitor. If you are not familiar with the HDMI interface, please see the previous TI Precision Labs video on what are HDMI and dual mode DisplayPort. The adopted trademarks HDMI, High Definition Multimedia Interface, and the HDMI logo are trademarks or registered trademarks of HDMI Licensing Administrator Incorporated in the United States and other countries. There are three major signaling components for HDMI devices. The first is the Transition Minimized Differential Signaling, or the TMDS channel, which carries video, audio, and auxiliary data. The second is the Hot Plug Detect signal, shortened HPD, which notifies the source that the sync device is connected. The last is the Display Data channel, the DDC. The source uses this channel to discover the sync's configuration and capabilities. CEC is a bidirectional Ethernet channel, and HEAC+ is the audio return channel. The DDC bus follows the requirements in the I2C bus specification for standard mode devices. There are three DDC signals, SCL, SDA, and the DDC ground. The DDC bus requires a strong 1.5 to 2 kilo-ohm pull-up to 5 volts on the video source side. On the video sync side, a weak pull-up of 47 kilo-ohms to 5 volts is required on the SCL line. All video syncs contain a CEA-861D compliance EDID data structure. The EDID communicates the capabilities and characteristics of the video sync, such as resolution and refresh rate. The video source uses I2C commands over the DDC bus to read information from the video sync's EDID. The source is expected to deliver only the audio and video formats supported by the sync. The DDC bus is used in HDMI 1.4 for reading the video sync EDID and other purposes. Starting from HDMI 2.0, a set of specific DDC registers, SCDC, or Status and Control Data Channel, were added to the video sync. Syncs that support SCDC must incorporate a valid HF-VSDB and set the SCDC present bit to 1 in the EDID. The video source must verify the presence of a valid HF-VSDB and that the SCDC present bit is set to 1 in the EDID before attempting to read SCDC registers. A video sync that supports HDMI 2.0 needs to provide a read-write control bit that is accessible by the video source through the SCDC. This bit is called TMDS bit clock ratio and will control the HDMI mode of operation. When configuring the TMDS for HDMI 1.4 operation, the video source must ensure that the TMDS bit clock ratio bit is 0 by writing a 0 or reading and verifying this bit is 0. When configuring the TMDS for HDMI 2.0 operation, the video source must write the TMDS bit clock ratio bit to a 1 first. HDMI 2.1 offers multiple data rates across the fixed rate link, or FRL for short. The video source selects the FRL rate and lane count by writing to the FRL rate bits in this register. The supported FRL rates and lane count are 3 gigabits on 3 lanes with lane 3 not being used, 6 gigabits on 3 lanes with lane 3 not being used, 6 gigabits on 4 lanes, 8 gigabits on 4 lanes, 10 gigabits on 4 lanes, or 12 gigabits on 4 lanes. Besides the FRL rate bits, the video source also sets the feed-forward equalizer, or FFE for short, levels bit to indicate the maximum supported FFE level for the current FRL data rate. The maximum supported FFE level is 3, which provides a total of 4 FFE settings. Please note that HDMI 2.1 requires the source to provide a compliant I output at the sync side HDMI connector, or TP2 EQ, with FFE 0. So FFE implementation is optional. With SCDC register 20 and 31, the video source can configure the video sync for HDMI 1.4b, HDMI 2.0, and HDMI 2.1 operation as shown in this table. Unlike the previous HDMI 1.4b and HDMI 2.0 specifications, HDMI 2.1 introduces link training. Link training is used by the video source and sync to prepare the video lanes for data transmission when initializing the link for FRL operation. A set of SCDC registers is used for link training purposes. The first register we will look at is the status flag register at offset 40. The video sync will set the FLT ready bit when it is ready for link training. The video source will constantly pull this bit and starts link training when a 1 is detected. If the link training is successful, the video sync will clear the FLT ready bit to end link training. The channel lane locked bits are set by the video sync when the sync decodes the TMDS data on each HDMI channel or lane. Clock detected is set by the video sync when it detects a valid TMDS clock signal. In FRL mode, this bit is set to 0. Lane 3 locked is set by the video sync when it successfully decodes the FRL data on HDMI lane 3. The next SCDC register for link training is the update flag register. The video sync sets the FLT update bit to a 1 when a value is changed in the register offset 41 and 42. The video source will continuously pull this register to look for a 1 from the sync. When the source reads a value of 1, it will read SCDC register 40 and 41 for the new value and write a 1 to clear the bit. Once the video source clears the FLT update bit, the sync may set it again to indicate there is a new value in register 40 and 41. If the link training is successful, the video sync will set the FRL start bit to a 1 to indicate it is ready to receive the video and audio data. The last two SCDC registers we will look at are registers 41 and 42. These 4-bit fields correspond to each HDMI lane. The sync sets these registers to indicate specific data patterns for link training, specific data patterns for compliance testing, request the video source to increase its FFE level if it is supported, and to change the FRL data rate. To recap what we've discussed, let's go over a short quiz. True or false? The video source does not use the DDC bus to determine the capabilities and characteristics of the video sync. False. The capabilities and characteristics of the video sync are communicated using the DDC interface. True or false? Link training is introduced in the HDMI 2.1 specification. True. Link training is used by the video source and sync to prepare the video lanes for data transmission when initializing the link for FRL or HDMI 2.1 operation. True or false? The video source can start HDMI 2.1 link training at any time it wants. False. The source has to wait until the sync has set the FLT ready bit. True or false? The TMDS bit clock ratio bit is set to 1 for HDMI 1.4b. False. The TMDS bit clock ratio bit is set to 0 for HDMI 1.4b and set to 1 for HDMI 2.0.